Hello world, it's Rahul. Welcome back guys to machine learning tutorial, and today we'll be going to discuss k nearest neighbor classifier. So guys, k nearest neighbor is a simple machine learning algorithm that categorizes an input by using its k nearest neighbors. It has various properties that differentiate it from other machine learning algorithms. Like KNN is non-parametric. That means it doesn't make any assumptions about the probability distribution of the input. Then KNN is a type of lazy learning, which is a learning method that generalizes the data in testing phase rather than during the training phase. Now suppose a KNN algorithm was given an input of data points of specific men and women's weight and height as shown on the screen. So guys, for determining the gender of an unknown input shown in green point, KNN will look at the k nearest neighbors, and where k parameter decides how many of the nearest neighbors have to be considered to determine the property of our unknown point. So guys, let's say here our k is 5. So it will look into only 5 neighbor points. If you can see, majority of 3 nearest neighbors are male, so the point is classified as male only. So it will determine that the input's gender is male. So guys, this method is very simple and logical way of marking unknown inputs with a high rate of success. But you might be wondering, how are these nearest neighbors found? So guys, this is where the mathematics comes in. So guys, KNN uses a similarity metric to determine the nearest neighbors, and that can be performed using many different notion of distance. So guys, Euclidean distance is the most popular notion of distance, where we calculate the length of a straight line between 2 points, that is unknown point and data point. And Hamming distance is the same concept but for string distance, that is calculated as the number of positions where two strings differ. So let's understand what is Euclidean distance and how we can calculate this distance. So guys, Euclidean distance is calculated as the square root of the sum of square difference between a new point and an existing point across all the input attributes. We will solve the problem with one example later on, but first let's understand where we can use this. So guys, we can use this method for both regression and classification problem. When KNN is used for regression problem, the prediction is based on the mean or median of the k most similar instances. So suppose we have data points scattered on the Cartesian. Now, if I want to predict for highlighted point and we have k value with us as 5, then we will look into nearest 5 values for this unknown data point and take average of all 5 points and consider that value as predicted outcome for unknown point. And guys, when KNN is used for classification problem, then the output can be calculated as the class with the highest frequency from the k most similar instances. Each instance in essence votes for their class, and the class with the most votes is taken as the prediction. So if you can see on the screen, for highlighted unknown point, again we'll look for 5 nearest data points, and we will check the majority of classes available among these 5 neighbors in circle and take that only as output class for introduce unknown point. So it's clear that in regression we take mean or median value of k nearest points, whereas we take mode of k nearest point in case of classification. So guys, let's quickly look into one real world problem where we'll try to find k value, Euclidean distance between points, and classify the unknown point. So now we have a data set as shown on the screen, where we have two independent variables x1 as acid durability of a paper and x2 as a strength of a paper, and one dependent variable y which will be categorized as whether a paper is good or bad. Now suppose we have produces one paper with attributes x1 as 3 and x2 as 7, and we have to classify it as good or bad. So let's straight jump into the solution. So guys, before going ahead, let me tell you that here we have to determine the value of k which is not predefined. But we have some assumptions for choosing the value of k, and rest is based on trial and error mechanism. As a small value of k means that noise will have a higher influence on the result, and a large value make it computationally expensive. So usually we consider an odd number if the number of classes is 2, and another simple approach to select k is set k equal to square root of n, where n is equal to number of data points in training data. So for our use case, let's say k is 3. Now let's calculate Euclidean distance for each data points with unknown point. So here our data point is x1 and x2 both as 7, and unknown point is 3 for x1 and 7 for x2. We will put these values in the equation and get it as 16. Same we will do for all data points. Now we will sort the distance and determine nearest neighbors based on kth minimum distance as shown on the screen. Now we will gather y variable of nearest neighbors, and guys, if you can notice, we have not included last column in second row as the rank of this data is more than 3, and we have to look only up to 3 values of k. Now we have 2 good and 1 bad. Since 2 is greater than 1, we can conclude that a new paper is categorized as good, because here in classification we have to take majority of category of nearest neighbor. Guys, before wrapping up this session, let me tell you where we can't use this algorithm. As we already know that KNN is sensitive to localized data, since KNN gets all of its information from the input's neighbors, localized anomalies affect outcomes significantly rather than for an algorithm that uses a generalized view of the data. So guys, suppose if there is any outlier present in the Cartesian for class A, and if we want to predict for an unknown point lies somewhere around class B and outlier, then there may be chances of getting the outcome as class A. If you can see on the screen, even it should belong to class B. So if we have outlier in our data, then this algorithm will not perform better. Guys, let's see another area where we can't use this algorithm. So guys, as we know that KNN is a type of lazy learning that requires most of KNN's computation be done during testing rather than during training. So this can be an issue for larger data sets. And just to add one thing, if we increase the dimension of our data, then also KNN will be failed to perform well. Guys, last but not the least will be normalization. If one type of category occurs much more than another, classifying an input will be more biased towards that one category, since it is more likely to be neighbor with the input. Suppose we have 600 data points for class A and only 15 data points for class B. Now, if my k value is more than 50, then there will be chances of biasness with class A, but this can be mitigated by applying a lower weight to class A and higher weight to class B. However, this can still cause errors near decision boundary. Thank you guys for your time. Do like, share and subscribe. Hit the bell icon to get the latest updates. Happy learning and stay safe.